spots up, and then I'm actually going to massage down the high point. What I like to do is I actually like to put my hand behind it to stop myself from pushing it down too far. I'll let that relax for just a few seconds, let it sit where it wants to sit. It's still a little low, I push it too far, so I come back through, massage it back up just a little bit more. Now we're actually going to taper the edges all the way around our hole that we have here. What that means, we're just going to dish it down slightly to actually give it so there's not a hard edge right there. What that will allow us for better adhesion better fusion when we're doing the plastic welding. If it's just a flat surface, we don't have as much surface area to actually do the fusion with. But if we give ourselves a little bit more of a surface area by just beveling the edge down a little bit, you have all that extra contact area where the fusion is going to happen. It's going to give you a stronger weld in the end. Deburring tool. Just grabs all those little flaps and just yanks them off real quick. Things you want to think about is which side do you weld first, right? And there actually is a theory to this one. If you're to weld from the front side first, and you take too long with your weld, or the weld doesn't quite go as well as planned, and it actually dips down on you, well then you're stuck with a low point right there, right? That's not too hard to fix, but then you still have to weld the other side of it. Well, then you go to weld the other side of it, and during that process, the same thing happens. The plastic gets overheated, it sags, and then you're left with a high point on the front side of the plastic. And the question you want to ask yourself is, what do you want to fix more? Fill a low point, or try to cut and fix a high point? You know, the option's up to you. Oh, I'm just going to put some aluminum tape on here. What that's going to do is it's going to stop the molten plastic from flowing down on us, or dropping, or sagging, or pretty much moving anywhere. We don't want that to happen. The idea is to keep all the plastic right where it's at. But that's also the challenge because we're melting it. What I'm looking for in here is I'm looking for the actual stamp on the bumper, right? The stamp will tell you what type of plastic it is. It'll actually tell you everything about where this bumper came from, how it was manufactured, what went into manufacturing it. I don't know anything else other than what the letters mean for it. So if we look on here, we find PP plus EPDM, right? PP is your polypropylene, and your EPDM is the additive that they add to the plastic. The additive will give it many different things. It could give it a strength, like a strong crystalline structure, so it's really rigid, or it could actually give it a lot of rubber compound additives to it, where it makes the bumper super, super flexible. It all just really depends on what the manufacturer is trying to look for in the material. Out here is we have the hot air nitrogen welding system, right? So what this is, we have a heating element that expands from this section right here, the welder, and it actually blows hot air out of here. And then when we're ready, we'll switch this over here and it'll actually start blowing just pure nitrogen out of here. Now what the nitrogen does is it actually stops the chemical reaction of plastic, right? Plastic, when it reaches the melting temperature, the chemicals that are inherent in the plastic actually cause a reaction with each other and the oxygen that's present in our air. So when you actually replace the oxygen with a different gas, which we're using nitrogen for, it stops the oxidation process, leaving no contamination and a proper fusion with the weld. So we're going to take this plastic rod right here, and we're actually going to weld it right into our spot down here. So the first thing I'm going to do is I'm going to flip over my switch. Now it has just the right pressure that I need for the welding, and I'm going to weld. Rod nice and melting in there. And I'm just going to follow around the outside of the outside of the hole first. Now once it's around the outside of the hole, now I have actual fusion to the bumper. Now everything else in the middle is just a matter of laying the plastic down. because it's all connected. As long as I don't break my connection that I have right here, I don't have to worry about the weld being weak anywhere. So now I've filled it all in. Twist it to get it to come off, lay all the plastic down. Then I actually want to smooth everything out, and I actually want to finish sealing all the welding. So I'm just going to blow my nitrogen over top, make sure that there's no oxidation happening while I'm smoothing out the plastic. What that's actually going to do is it's actually going to stop any weak points from in the weld happening just by smoothing it out. It's a Scotch-Brite pad. You can use a gray one, a red one, a blue one like this. The blue one's supposed to be the least abrasive out of all of it. And you really want one that's just worn out completely. That's actually where we get a really good polishing of the plastic. When it's really abrasive, it just starts melting the plastic, it starts smearing everywhere. That's not exactly what we're trying to gain out of this. We're trying to get out of this, we're trying to just spread out the plastic nice and smooth, make it so nobody can really see that we did any kind of work to it. Now I'm actually going to place this over the back side of the weld that we just did. Because of the area where we're at, we can't really support it very well. So what I'm going to do is I'm going to take multiple pieces of this metal tape and I'm going to lay it down to try to give myself some sort of backing. So what I'm going to do now from the front side is we've supported the back side as best as we can. So now what we're going to do is we're going to come to the front side and we're actually going to finish up our weld. What I'm going to do is I'm actually going to build up the plastic a little bit more from the front side just because of the damage actually took away quite a bit of the plastic right there. So I'm going to start with my welding. I'm going to weld right around the outside. Just like I did on the back side, this is going to give me the basis of what everything else is going to hold to. I did before on the back side, I'm going to keep my nitrogen flowing. That's going to stop any oxidation that could potentially happen at this point. That's going to keep the weld nice and fused properly. And before we start gearing it down, we want to make sure that we cool the weld off like thoroughly all the way. Until the weld is actually fully set and cooled off to room temperature, it's still very weak. Once it reaches the room temperature, the weld is actually strong again. That's what we're doing. Now we've actually got the room temperature, now we can actually sand it down, we can shape the plastic, we can actually get it ready for the final stage, which is the filling. We have to put a filler over top of this, and we're going to use a flexible 2-part filler from 3M. It's 5887 is the order number for it, but before we use that, we have to use an adhesion promoter to actually cause a molecular bond with the plastic. It's just a light coating, not too much. So what I've done here is, most of the plastic work is done in here. Everything else that would need to be done to this is just DEAing it out and finishing it off, getting it ready for primer. All our plastic work has been done. The plastic is straightened up to the point where just the DEA and a little bit of blocking would be necessary. Other than that, we should be ready for paint.